debate session. The format has been posted on the workshop, so I guess I'll skip the intro and explanation of the format. But basically, we'll have at the beginning we'll have 2.5 minutes for each person, starting with each side, and then follow up with the other teams. We can start with the introductions. By the way, I would like to invite all of you who have not filled the poll before the debate to express your opinion about the topic. Basically, the topic we're having today is two options. In the future, construction will likely to be carried out by autonomous robot with minimum human workers. This is option A, and the team A supporting this would be Michael, Noah, and Martin. And then option B is supporting the view that in the future, construction will likely be carried out by human-robot collaborative system with many human workers. And team B will be Bharat, Dr. Danish Manocha, and Chris. Right now, what you're seeing on the screen is the real-time poll. So we're quite split, very nice. And after the debate, hopefully, let's see whichever team can convince the room and change their opinion. So without further delay, I guess we can start from team A. Yeah.
Yes, right?
Yes.
So this is not the opening statement.
This is the
as when we're getting into it.
This is just an introduction for the team. So at the beginning, we'll have 5 minutes introduction split between the two teams. Each team have 2.5 minutes. After that, we'll have 10 minutes opening arguments. Again, so basically we have 6 groups.
Okay.
You get to
So
2.5.
just quickly go through the 10. Okay.
Yeah.
Sure. So as you probably saw this morning, if you're here, my name is Michael Milford. I'm Joint Director of the QT Center for Robotics. And I guess the perspective that we're bringing to this debate is years and years and years of very fulfilling and interesting, but also extremely painful attempts to learn how to translate fundamental research, which is what you're primarily seeing today presented at the conference. And I think we had a bit of a fundamental research bashing session this morning, gentle bashing session, into actual deployable product that stands up to the rigors and turmoils of the real world. And I think that is the perspective I'll be bringing to this debate.
My name is Noah Reed Campbell. Again, I'm the founder and CEO of Built Robotics. We develop an exosystem, basically an upgrade package for excavators in order to turn them into autonomous robots. And I think that in my view, the key question for this debate is how far in the future are we talking about? Something that the point that Michael made as well. I suspect that we probably actually will agree if we define that term, but that's okay. It'll still be a fun debate. And Martin is my colleague here.
Hi, my name is Martin Carlson, Senior Robotics Engineer at Built Robotics, working mainly on controlling and automating movement of excavators.
It's coming through. All right. Hopefully. Just about. I'm Bharat. I'm the CTO and co-founder of Scale Robotics. A little bit about my background is, though I work in construction robotics, now I started my career as a space roboticist, moved into manufacturing automation, did autonomous driving, autonomous flight, humanoids. And then I realized, oh, this is easy. Let's do construction. And I was like, that's a bad idea. And the fact that I will be and the team will be representing is that we're trivializing construction a bit too much to think that we can automate everything in there. I've spent my last 6 years on a lot of construction sites, not exactly what I got educated to do, but I was like, okay, this is a learning experience. And I think we're trivializing the problem. To your point, how many years is one thing? And what do we mean by construction? Are we talking about on-site construction, off-site construction, or home construction, or what kind of construction? Lots of open questions.
Thanks. Hi, I'm Chris Moore, and I'm the head of robotics and visual computing at Hilti, leading our research efforts. So Hilti has actually launched construction robotics to work indoors and in the field. So I'm bringing our experiences in that and what it takes to actually deliver and execute automated tasks in the field. And we strongly see the user, the human still in that loop as a kind of the creative nexus to really execute all these complex tasks.
Hi, I'm Dinesh Minocha. I'm University of Maryland. I guess I'm on the academics hardcore along with you at Brisbane. So I've been around for robotics for 30 years, lived through a lot of robotic excitement and hype, right? And, how many successful robotics companies are there besides the mission industry robotics? And we all heard about autonomous driving this morning, right, where that is heading. So keep in mind, robotics, building autonomous solutions is not easy. And building autonomous solutions that can work in messy place like construction site, on-site, or even off-site is not easy. There's just lots of challenges, lots of problems comes up there. So I think it's something we're excited about. There's a lot of potential, but let's also be realistic. Thank you.
Hey, we have 3 successful robotic companies right here.
Great in time. Next is the opening arguments. We have 10 minutes, which means 5 minutes for each team. I would encourage you to start from team A and then reduce which.
All right, so this is a debate. We're going to get a little competitive, and then I think it will be revealed what our actual opinions are at the end. So let's talk about, we've got to take the debate's topic at face value. So it says the future, and the future is from 1 second to infinite time from now. So the future, by definition, is a very long time into the future. It's not the short term. And I'm going to make the argument, I'll kick us off, that saying that, premising that this field is going to be heavily collaborative with humans is short-sighted and ultimately short-selling the upside potential of automation. You're going to hear from our fellow team members or fellow debaters that collaboration is a result of the shortcomings and limitations of current technologies and the fact that progress is slow. But that's not what this debate is about. This debate is about the long-term future and the potential upside of what you can get to in construction. Collaboration with the human worker also undervalues the role and value of a human worker. It puts the human worker scrabbling to fill in the shortcomings of what the automation technology could not do. And that is fundamentally not a tenable solution in the long term, because you are devaluing the role that the human plays and you are letting them play a subservient role to the technology to make up for that technology shortcoming. So from a labor workforce point of view, and moving away from the jobs question, you're not starting with a human first approach necessarily. And I guess the third thing is collaborative working with humans in the workspace is by definition limited, because we've heard time and time again that the real transformative opportunities in logistics, in mining, and a lot of other areas is what happens when you take the humans completely out of the workplace, because then you have a number of very liberating options in terms of how you deploy your technology and what you can do when you don't have to worry about squishy, unpredictable, delicate humans coexisting in the workforce with your automation. So once again, it's an argument of, if you're really thinking about the future, the potential upside, the big upsides, the transformative upsides result from a pretty much fully automated construction worksite.
Oh, sorry.
Yes.
All right. Maybe I will start with the future discussion too. As time evolves and as automation increases, the complexity of the task you execute becomes small. So automation never truly catches up. Best example, let's take surgery. Back in the day, we were cracking people's head open and giving them alcohol to stick something into them. Today, we do complex surgery, neurosurgery, or different forms of surgery. And it's just that as automation has evolved, we have a machine called a Da Vinci. The kind of surgery we do is way more complex. Same thing goes for, let us take autonomous driving. Your first ADAS system was basically the flaps on the ear of a horse. It is a lane assist system. It's just telling the horse to go straight. That is a form of autonomy. And then as that autonomy started evolving, the cars got more complex. They got internal combustion engines. We started adding more complexity. And as vehicles are moving forward, the complexity of the task being executed, and also the person executing the task is way more qualified. So this is how you should think about when we say collaborative effort is the robot, the automation becomes a force multiplier for what task is being executed. You get someone who is riding a horse carriage and put them in a Formula One car, they will not be able to execute to the same extent. But now the competency level of the average car driver is way, way higher. Why does this become the base point for our side of the argument? Because this goes to something I said in the presentation. If you're going to automate something, it has to be either better than humans, cheaper than humans, or both. And the problem is every time we update with technology, our expectations of what it needs to accomplish starts increasing. So the technology will always be there to supplement. We have the best supercomputers in the world, but you are still writing the cost function and defining the optimization objective and not leaving it entirely to the system because the expectation is much, much higher of how these things evolve. Then there is just a practical thing of robustness and reliability. The technology will update. You have something that was previously not robust, now a trivial task. But then your expectation of where it needs to be robust and what needs to be accomplished will increase. Hence, you will always be catching up to an objective function that evolves over time. And to kind of add a bullet point to all of that is outside of, structured environments, controlled environments, which is manufacturing automation, where we've had a lot of success. In unstructured environments, I guess in the last 20 or something years, literally the only robot we've deployed at scale in unstructured environments is a Roomba. So this should tell us where we are sitting as an industry or as a field. Just to re-quote Rodney Cooks, we haven't put anything out there that's more successful than a Roomba, and a Roomba bumps. So.
So I think that this question is actually not just about construction robotics. It's really about robotics in general. And the reference that I would like to look to here is Star Trek. In Star Trek, they live in a post-scarcity economy, and everybody just picks a job that they find fulfilling and interesting. And of course, it's science fiction, it's a little out there, but I think that actually is the world that we will get to. Or maybe we'll go extinct for some reason, that could happen too. But I think as long as we don't go extinct, we will eventually get to a post-scarcity economy. And the way that we will get there is through automation of almost everything. And people will really just, maybe a lot of people will play video games, and then some people will go out and explore space. And so I think that if you kind of look at this with a, not even just like a multi-decade time scale, next few centuries, we will get there. But I actually would say that, within the next few decades, I probably am kind of on that side. I do think that, one of the biggest lessons learned here is, job sites are hard. People are incredibly capable, incredibly flexible. We have a partnership actually with the International Union of Operating Engineers. It's a 400,000 member union that represents operators in the US and Canada. And it's all about training. It's all about training the human operators to know how to effectively utilize robots, which are tools at the end of the day. So I think it's just really a question of the time scale and where things are going, not just in construction autonomy, but in autonomy in general.
So to use maybe a cliched analogy, a construction site is like an orchestra, right? We have all these skilled players all coming together, all leading towards this great piece. And the future of robots and humans together is we are taking our individual players and automating them, but keeping the conductor in place. And this is the role and why humans will always be involved with construction on the site. That this level of creativity and flexibility and adaptability that we've already heard and seen examples needs that spark in order to organize the individual tasks. Is it raining today? Do I have to modify my approach? Did something come unexpectedly? What do I do to change my schedule? The ability for the human to instantly recognize the problem and to direct their robotic orchestra into adapting to the on-site conditions is why we'll always have people on place.
For the one for each.
I would almost say that the amount of human work opportunities is being minimized all the time. So there are no companies that invent jobs that they actually don't need and hire somebody just here to sit there and take up a spot. There are still a lot of job opportunities in the world, and the amount is actually increasing, and they're changing and so on. But they are definitely not maximized by purpose.
Just quickly, you use surgery and autonomous vehicles. The fundamental difference is surgery by definition is a human-robot interaction problem because you are operating on a human. Autonomous vehicles that exist in cities are by definition a human-robot interaction problem because they are existing with pedestrians and cyclists. Construction sites, a fully automated construction site by definition is not a human-robot interaction problem because you remove people out of that zone. And the other factor is if you insist on having hundreds of thousands of humans on construction sites, no matter how well you do it, you will still be killing and injuring large numbers of humans in the industry. The only way to get that down to zero is to remove them completely from the danger zone.
I'm going to first let Dinesh make his statement and then I'll jump into the bottom.
We have about 20 more minutes to discuss.
Well, we all talk about Star Trek. This is a panel on realistic world, not science fiction, right? So there are all these projections about, I think I read somebody in 1930s predicted we'll have flying cars, right? So there have been predictions, right? And I want to have two questions, so rather about what is future and what is automation. We can debate for 5 days on that. First of all, you look at this about construction, this morning it's 4% of US GDP, 11% of worldwide GDP. How much of the construction is really automated right now? Is it even 1%? Okay, so we are at a scale where not even 1%. Let me ask a different question, how much 10 years, can we 10 years go 10% construction will automated? Can you reach that target? I don't know, number one. And secondly, talk about human surgery and everything. There's one place where automation has got a lot of attention to the construction is factory automation. Even if you look at the history of robotics from 60s, 70s, I see the picture, the first industrial manufacturer deployed by General Motors. For some kind of a job, they're 50 years ahead of construction industry, construction getting up. How much of manufacturing, and you talk about manufacturing and construction, a good example to show. How much of manufacturing and factory automation has been automated? We are seeing a few success stories. We hear about Amazon warehouses. We saw about some companies, some automation that COVID has led to automation. But how much success have we had in those domains? So, and how much will construction to go? So, given how much progress we have made in the last 50 to 100 years, extrapolate. So, if you say time is infinity, yes, everything is good. But I'm thinking about 10, 20 years. That is still a long way to go.
I think we have now entered the moderated discussion session. We have 25 minutes where it's basically free debate and also with challenging questions, hopefully from the audience. So if you have any different opinions that you want to ask, you can feel free to come here and ask the question. But while the audience are preparing for their challenges to our debaters, you guys can start.
So I'll probably just respond to Michael on the fact that he mentioned that construction is not a human robot interaction problem. And I would say it is. And this is what happens when we get stuck at a robotics conference. I also have the opportunity to occasionally go to architecture, construction conferences. If anyone knows what a biennale is, it's the largest consortium of architects, designers who come together to talk about what the future of not construction, what is the problem construction trying to solve? It's addressing a fundamental human need of shelter. How is shelter evolving? Are we still going to be living in physical buildings? Are these going to be modular components that just drive together, assemble when you have to be at home and move to your workplace when it has to? Are we going to grow our shelter? So to say that construction will always be a one-way task, where you can just autonomously execute and leave it there, and not as an evolving entity, is probably looking at it, that entire field from a very siphoned view as a roboticist. Then there is the secondary point is it is still a human robot interaction task, just slightly delayed. A human is going to live in that space. It has to be certified. And the imprints of this is seen very well with the earlier point I made about the complexity of what you can do will keep evolving. Just look around the room. We've got sharp corners in practically every wall. Anyone who's taken any basic high school physics course knows that sharp corners don't distribute loads well. Why do we build it this way? So that humans can assemble them, because we were limited by our technology. As the technology advances, we won't be building the same stuff. We'll be building more complex stuff that distributes loads well, and their automation will always be lagging back. And as it moves, and you see that today, the most futuristic, where what I would call livable optimal kind of sites, there is the Gramazio Cola group at ETA. There are a whole bunch of people who are trying to work on these things. Robots are great. Then you always have someone who has to come and finish all that off because it's just too complex. And when the autonomy catches up, then the architects will introduce us to a whole new level of design where they'd say, okay, now start building this. And then you realize, okay, my autonomy is not there yet. So there's always this catching up to do. And where I do see this going is because of the limitations of the industry, because of the way it is built, we still think about build structure as something that is fixed in time and not as an evolving entity. We are seeing that change right now. If you have seen one of the big effects of pandemics, is we built a lot of data centers because all of us have moved online. I don't know, most of you are familiar, a data center's life cycle is 3 years. They strip it down entirely and rebuild the whole thing. And this happens with most facilities. There's a reason you have like a building collapse or a hospital having issues, is because we treat it, because of our limitation of technology, as a structure that's not evolving over time. The moment you take those factors into consideration and look at it from the industry standpoint, and not as just as we do as like roboticists, you will start making very good arguments for why this will never be fully automated. Okay. Or at least the route automation is not like from robots on site.
I think we should give teammates some chance to respond, and then we'll move on to
Just quickly, you mentioned pandemic. So in Australia, this is not a made-up example, significant parts of the entire construction sector shut down because you could not have vulnerable, transmissible humans on site. And you could argue that that actually had some influence on the federal election that just changed government. And so once again, fundamentally, if you have squishy, vulnerable humans on site, no matter how good the technology surrounding them is, you are always going to introduce a level of hazard.
The debate resolution poses the question of a construction worker and like the trade-off between a robot and working simultaneously with construction workers. We've talked about human-robot interaction, but I think that I would pose this panel to the question of how are we defining construction worker, and if we're taking the task, the menial repetitive task away from a laborer and adding a creative or design element to someone who's operating a robot, is it still a construction worker?
That's a wonderful point you raise. It also forms the natural rebuttal to what Michael just mentioned about the squishy human on the site. There will still be a construction worker, just that worker may not be sitting on site. We do a lot of robotic assembly in space. Not everybody's standing on the structure while they're doing it. It's happening remote. So we have to think about this entire problem in a different way. So and this is something that we tend with, I think Noah is probably also familiar with this bit, is the skilled labor shortage is also because people find construction boring. Nobody wants to go do the same jobs that their parents did. Yes, there are larger economic margins in Australia for them to be incentivized to do it, but other places it's not the case. So the definition of who a construction worker will evolve over time, and that's how you see it, as someone probably tell you operating a robot. Just Google Harvard computers and see the first image that comes up. There were a bunch of mathematicians sitting in a room doing math with logarithmic tables. That's evolved. Today, a computer is something you keep on your desktop. So there is a way, but the skill of the person operating the machine is exponentially higher. And what they can accomplish with that machine, more than the skill, I would say, the task they can accomplish is way more complex than what someone with a logarithmic kit can do. Sitting and doing, basic math and calculus calculations. So the definition has evolved. You guys want to add into that before I get?
I think I just want to point out there was a false equivalency that I want to jump into there. So the end user is us. We are the people who inhabit our buildings, and we should be consulted, and we should see how these infrastructures and buildings impact on us. But that does not mean we will be the people designing even the artistic side of architecture. We have seen a trend, and horrifying as it seems now, where modern artificial intelligence techniques are capable of increasingly sophisticated, whether it's true creativity or faking it as if it's creativity is another argument, but they're able to create things that were traditionally thought to be purely in the human domain. And so yes, the end user human will have to be consulted on whether they want to live in this whatever this proposed building is. But the people doing the creative and innovative design, they may be, once again, automation, not people.
I want to add the most boring point ever, legal framework. So what is a construction worker? It is a person who is subject to the legal framework in which they're working. And one of the things preventing full automation and why humans will be involved for quite some time is simply the fact that there needs to be a person on site who is legally responsible for the actions that are being taken. And if that person is not on site and you have a bunch of robots running around by themselves and they make a mistake, then the liability question is open. And at the moment, operating robots indoors is not strictly regulated because it's happening so seldomly that there haven't been so many disasters yet that the government has set in. But unfortunately, we know that this will happen over time, and then there will be a regulation that will almost certainly involve a person in the loop.
I think it's a really good point. I actually would say that it's not even unfortunate that the regulatory frameworks will roll out. I think it's fortunate. We need to make sure as an industry and as academics that the regulatory frameworks that do roll out are intelligent and make sense. One of the great things about construction equipment is that you can usually just stop if something bad happens. You can't just stop on a highway. You're going to cause a traffic jam or maybe even an accident. And certainly in the case of drones, if you just stop, you're going to fall out of the air and you're going to actually maybe cause an injury. So I think that for our space, it's actually, I think it's more friendly. It's possible to make these robots operate in a safe way. And I don't think that we should shy away from it. But I would say that you can actually make these robots. I think we have to confront the fact that these robots are going to be operating autonomously, and that we, the manufacturers of the robots and the developers, actually need to take on that liability. I mean, the robots need to be run in a way that complies with the the training and certifications and everything that we develop. But we need to say, hey, if the robot is not run correctly, then that's on the REO, the robotic equipment operator. But if it is run correctly, then it's really on us, and we have to make sure that the robots do what they're supposed to do. And we already see that. We actually have our robots running today on job sites with nobody around, and we're ready to stand by them and ready to warranty them and say that, hey, they're going to perform correctly. So, I guess I think I partly agree and I partly disagree. So.
Actually, isn't that point supporting team A because of the liability? You want to remove people from the job site, so it's more autonomous. No,
that's a separate point.
You're not allowed to do that.
Sure, I guess.
The point I wanted to bring up is kind of the history of kind of a little bit of the automotive industry is somewhat similar to construction a little bit, where automotive started out with a lot of people doing artisanal kind of parts of the car assembly and then moved to manufacturing and getting more distributed work, which makes it more automatable. And thus more lights out kind of package standpoint.
how does panel see construction? Can it get to that kind of point where have more prefab and have more manufactured components where we could have a fully automated construction process that would help?
So, the liability is a very difficult issue, because if there's always debate about, this paradox, right? If an autonomous car has to hit between person A and person B, right? And if something goes wrong, who do you blame? The car manufacturer, the software, or the algorithm developer? That's a whole new challenge. But I think keep this in mind, that automation is really hard. And those of you who work for a long time will realize it is not easy, especially the kind of capabilities we need. I repeat again, construction sites are one of the most messy places for automation to work. So developing that kind of technology, so it's just too many situations, too many unsolved problems, and expecting that we will have solutions that we can replace human in any foreseeable future is just long way to go. Because the problem complexity is so difficult, and we don't have much success story besides Roomba bouncing in the room for the last 50 years that give us confidence that in the near future, my future is on infinity, 10, 20 years.
I was going to average infinity and 1 second to a very long time period. I would just point out that a lot of this is the same thing that's happening in mining. So a lot of the thinking is, and I'm not saying this in a negative way, is short-sighted in that they're thinking how you adapt current construction site practices and process workflows to introduce automation. And of course, that is going to be limited and very challenging. But in the mining industry, they have this concept of the electric or fully autonomous mine. And if you start from the very start with an entirely autonomous process, it liberates you incredibly. You don't have to make the site safe for humans. You don't have to make accessibility safe for people. You can drop ship in equipment in ways that you would never do on a site populated by humans. So if you start with the idea of the site being fully autonomous, it's incredibly liberating and also potentially incredibly economically lucrative.
Go for it.
Yeah. So I can agree with the other team about if we're talking about 10 to 20 years, there will definitely be a lot of jobs, maybe even on site for humans, but definitely on a supervising level as well. So in our case, we make excavations. So a human will tell the robot, like, this is where I want the trench to be dug, for example. And the robot won't probably take too many initiatives there, at least follow a blueprint that a human made. But then there is the unforeseeable feature. And then I think what can be automated will be automated. And I think both team agrees about the first thing we're aiming for is the mundane, dull work. That's very repetitive. And that's a nice coincidence because it allows the person that used to work with that to work on a higher level, supervising, specifying, and running several robots, which is more fulfilling and also scales very nicely. And the thing that's nice is that that's also the thing that's easiest to automate. But then if you in several million years eventually get superhuman level intelligence in the general sense, so computers that are better than us in all intellectual tasks, then where will the human be in a construction site? And I think at that point we won't be able to add any intelligence. We already don't add much hardware to the construction site either. We have pretty sophisticated hands, but yeah, it's mostly like manipulation intelligence, and we are the ones that tell the robot what we want the end result to be.
So maybe I'll address a few points over here also to get to your question. Let's talk about like liability, and then I'll try to bring this together to where prefabrication and things come in. I worked in manufacturing automation for a long time, to the extent where these outfits. And I don't like using anecdotal examples, but to give you a feel of something that Dinesh also brought up earlier about where the industry heads and where the liability question comes in. Manufacturing automation, for it to work efficiently, they did get a lot of people off the shop floor to the extent that basically no one is there on the shop floor. And the place where I was working is solar conductor manufacturing. It was 95-96% accurate. Current robotics technology is nowhere close. 95-96% accurate, but there were still operators who were remotely watching the floor. Because what they did is they had to re-engineer the entire supply chain, but there was still a liability cost of who's responsible if the machine breaks. Because there's a classic economic, I agree and disagree with what Noah says. Agree because he's a friend, disagree because I don't agree with the principle. Is you can't sell it at scale if the component manufacturer says that I'm going to be responsible for any damage that this device will cause. This is like, selling a Da Vinci robot for doing surgery and then someone's operating it and it screws up. Or your phone, you're the user of the phone. Apple is not telling you, yes, they provide you basic warranty for operation, but if you do something else with it, they can't be responsible for you using the device in any way possible. So there will be some kind of shared liability. Hence, there will be people on the construction side. The second point about automation is about spreading the liability of where this, and this ties into the automation bit. When you think about a construction site, you're very siphoned in and focused on the whole on-site construction. If we break it into prefabrication, on-site assembly, then there's a lot of complex works that happens on-site. There, you're breaking the liability chain into multiple pieces. You prefabricate something, you're done with that bit. There could be robotic automation there. Then there is some form of assembly where there'll have to be some kind of liability and who's assembling, because even if you're not physically assembling it, someone has to be responsible for it, or someone who's saying that this is the assembly structure and this has to go according to this. Either is the person who put together the model, or the site manager, the site supervisor, all of these things, and mostly it might be a site supervisor because of the unstructured nature of the environment. Final step, again, where automation liability, all of this comes in, is liability increases as the complexity of the task increases. Liability reduces as the complexity of the task reduces. So if this task is very sensitive, someone is obviously going to be there on site to do this. And since we do construct for people to live in, and if the building collapses, they don't go ahead and catch hold of Caterpillar or some other company that sent the machines. They catch hold of the people who built it. You can make the argument for why there will always be people involved. Yeah, we get another shot at this.
Oh, no.
Maybe you can add one more point. Yeah, go ahead. Think about another unstructured environment where we have automation and why it's not gone full. And I'm very guilty of doing this in my own doctoral thesis when I presented it years back. Oh, nobody wants to do their dishes. So let's get a humanoid to. That's so painfully stupid to think of it. There is a robot that does your dishes. It's called a dishwasher. You took out the hardest part of the problem, which is just mounting the dishwasher. Then this system does the repetitive, really hard task really well. That's how we should think about automation, or not like, should I build a super complex machine to do dishes in the sink? So construction will also evolve the same way. Like there'll be particular tasks that will be entirely automated, and the really complex tasks humans will still be involved.
Forgot one more thing. Somebody needs to fold my laundry.
That's another painful one.
We haven't found a dishwasher for laundry folding. So I think the conclusion is become clear. We really need. We do it. One more thing I should mention to you besides that job of repetitive tasks. Like their jobs are dangerous. Like when we deployed this system with Baidu, it was a toxic material. So that's definitely where you need automation. Basically, because really safety is also very high. Given how that really comes up. So I think that clearly we are seeing that there clearly some very wonderful potential, some repetitive tasks, and some dangerous tasks where we should deploy automation solutions very quickly. And I do believe, in spite of that, the automation technology has come to a level that some of the problems are solvable. Not everything is solvable, but some of the problems are solvable. So given the number of tasks in the construction industry, I do see some potential. We should invest much more, and we can see some good success, and that literally pays way through. But expecting all 100% in the near future, that will be too hard. But that should not be a discouraging point. There's a lot of potential of making a lot of strong impact in the next 20 years, in spite of not 100% fully automated.
I come from CMU, and actually, I'm maybe me and my colleague, maybe brilliant individual, because we are treated like educated as an architecture designer in like maybe 5 years ago. And also, I personally work as an architecture designer on site. So actually, right now, I'm fully agree with the human robot interaction side. Yeah, because I really communicated with those construction workers on site. So typically, we draw those blueprint and also like very detailed joint in our office. But when you send it to the construction site, actually nobody will care about what is this kind of things should be done. And every workers, they have their own experience and also have their own techniques to dealing with those joints. I know the other team will argue that maybe if we remove all those workers from the construction site, we can send those blueprints directly to the robot and make everything perfect. But one question is, do we really need those kind of accuracy for the architectures? Because the construction robot, for me right now, we're dealing with the robotic arms, and to calibrate every time we use the robotic arms, we have to like calibrate it like close to 1 millimeter resolution. But for the construction and especially for the architecture, that will be fine. Even if like 10 centimeters like shift from not for the columns but for your for the walls and something that is tribute. Yeah, and also I think that would be more interesting for me if we can discuss a little bit about the role between the construction workers and the robotics, because right now in the near future, just like the teammate said, in the near future we cannot just remove everybody from the construction site, and so the question is, what the relationship between the construction workers and the robotic arms or robotics? Like if we want the robotic to serve as a servant for the construction workers, or we want the construction workers totally control the robotics. And even I think in my rudimentary idea, even if we remove all those construction workers from the construction site, we have to have someone to control the robot control the robot far away or remotely. And I noticed that in your company's presentation, there's one voice like coming into your maybe construction site, and your robot will just stop. And I think that's some kind of human robot interaction.
So this question is quite long. I guess I will because the question is directly for teammates and challenge teammates. Can I just ask?
Okay, we can totally do it.
Okay. Sure. I guess we just have a quick wrap up, and then we'll move on to the closing.
Okay, like you said, there are a bunch of interesting questions there, so thank you. Maybe I'll grab one in the middle there. What does human-robot interaction look like? Can it look like on the site today? And I think when we're talking about near to mid timelines, there absolutely will be this transition, right, of bringing more and more robots onto the site. And that means we have to think about what that interaction looks like. And there's another factor we haven't touched on yet, which is robots are super, super expensive. And you mentioned robot arms. You know, standard robot arm is $30,000. You look at some really interesting concepts that have 3, 4, 5 arms. You're talking about, you know, $300,000 a robot. That buys you a lot of labor. And the business case, I think you talked about it right off the tech, that we have to be able to solve these problems that economically make sense. Means that we have to build robots that potentially are really focused on one specific type of problem, a problem that's either no one wants to do because it's dangerous or it's miserable, and it provides that economic benefit. So the way that a person and a robot interaction can be right now is very conservative, right? You've got your compliant arms where if you touch it, everything is a full stop. But in the future, we want to get closer so that we're actually having the robot being an assistant. An example of the prefab, say you've got an MEP prefab yoke that comes on site, it's this big unwieldy thing. Well, your robot can pick up one half of it and I can pick up another, but now I need to communicate. Am I communicating through gestures or am I talking to it? And then how does it tell me information back, right? So those are just some of the practical problems that we're dealing with and why that person is still in the loop with that robot.
I think Pierre will have one response and then we'll have to.
I don't know if we necessarily have a response directly to that. Maybe we can jump to closing arguments.
Okay, then let's start with the closing. So basically, at closing, we each get 2 to 3 minutes to summarize your points, and we can start from.
I see what you did there, Michael. Classic debate, so that, you close, I'll close with the stronger point. So I think there's, what is the timeline, the future? I understand this is an academic conference, but part of, I'm glad I'm on this side of the aisle, is just to make sure that we start having impact. It is an industry that is crying for impact, and trying to solve the wrong problem just does disservice both to our field and to the industry. To quote, I'm not sure, I think it was John Glenn or someone who said that as an engineer, your job, we like to call ourselves scientists, but we're still engineers, scientists of physics, chemists, biologists. As engineers, our job is to build things that work, and they should solve problems. And unfortunately, we are not very close to that because we are lost trying to solve problems way into the future. And so what matters now, what matters today, and what can have impact and actually stay. And let's face it, we are on a crash course with climate change, economic downturn, all of these problems. We don't have the luxury to start working on problems that are 150, 200 years away. Let's start solving problems that affect us today. Construction is one of the largest pollutants, has the largest economic impact. Let's put solutions out there that will be useful within the next few years, and thinking what is the universe going to look like in 150 years. We may not even be there to enjoy that. So that would be my final argument of why we should think of it as a joint optimization where humans and robots are involved.
So I think we have some future political leaders in the room. So the actual question we are trying to answer, not the question we're trying to reframe to, is in the future, which is into the distant construction, will there be lots of human workers, which is their side of the debate, or minimal human workers? Not no human workers, minimal human workers. And basically, a lot of the arguments you've made support our side of the debate. The other thing that you've heard repeatedly is we've made so little progress in the past, and this is very hard. We agree completely that it's been very hard and progress has been slow, but this is a forward looking into not just the short term, which is how they've reframed the argument, but that is not what the discussion is about, into the short, medium, and longer term. And just because progress has been slow is not a valid or a strong point to saying we cannot get to this point in the future. And I just close with 2 more points. One is construction doesn't have to bear it alone. So the argument's been constructed as liability is this problem that's a big problem in construction, but autonomous vehicles, artificial intelligence and robotics in defense, they're shouldering a lot of the heavy lifting around liability, around human in the loop and where they need to be. So construction does not need to solve it, and hence will make more progress than I think they're giving us credit for. And finally, to go to precedent, there were people sitting around the table making exactly the same arguments about why we wouldn't progress just before the Industrial Revolution, just before electronic computers became widespread, and just before the internet became widespread. So that's our closing argument. Thank you.
Thanks.